This is the lecture for section 7B about combining probabilities. The first probabilities we're going to look at are called and probabilities, and we're going to look at and probabilities that are independent events first. So first we need to discuss what independent events are. Well, two events are independent if one outcome does not affect the other. For example, me rolling a die and then flipping a coin. They are two completely different events and one does not impact the other. Just like me rolling a die and then Susie rolling that same die. How I roll the die does not impact how Susie's going to roll the die, and it doesn't determine what number is going to come up. If we have two independent events, A and B, with their individual probabilities, we can find the probability that A and B both occur together as the probability of A times the probability of B. And then this can be extended to any number of events. So maybe I want to find the probability that I roll a 6, and then Susie rolls a 6, and then Joey rolls a 6. I can extend it past two events. So that example I just mentioned of me rolling a 6, Susie rolling a 6, and then Joey rolling a 6, what's the probability of that happening? Well, the probability of rolling any 6 on a die is 1 out of 6 times. So that's me. And Susie rolls it. She's got a 1 out of 6 chance of rolling a 6. And then Joey rolls it, and he's also got a 1 out of 6 chance of rolling a 6. And if we multiply that, 1 times 1 times 1 is 1. Our denominator 6 times 6 times 6 is 216. So in the end, the probability of all three of us rolling a 6 in a row is 1 out of 216. The other type of and probability is when we have dependent events. And two events are dependent if the outcome of one is going to affect the probability of the other. So for example, a gumball machine. The probability that I get a red first, and then somebody coming after me getting a red is going to be different because my gumball has already come out of the machine, and that now a number of reds in the gumball machine is different than what I started with. So the probability of A and B in this case is the probability of A times the probability of B, given that A has already happened. So there's going to be something slightly different with the second probability to be able to get us our final answer. And just like the other one, it can be extended to more than two events. Let's look at an example of jury selection. A 3-person jury must be selected at random from a pool that has 6 men and 6 women. What is the probability of selecting an all-male jury? Well, we have a total of 12 people. And what we want to get is we want to get a male followed by a male followed by a male. Well, if I first pick out of a hat, I've got 6 men total out of 12 people. Once that slot has been filled, I now have 5 men remaining and 11 total people. So the second probability is then 5 out of 11 because there's 5 men remaining out of 11 total people. Once that second spot has been filled, 2 men and 2 people have been taken out of the selection. So I'm now down to 4 men to choose between 10 people that remain to be chosen from. And then I can multiply across. 6 times 5 times 4 is 120. 12 times 11 times 10 is 1,320. And that comes out to about 0.091 or about 9% chance that I'm going to get all men. And just so you know, I will accept either one of these if you were doing a show your work type question. But Pearson will usually tell you, hey, use a fraction, or hey, use a decimal. So just make sure you're reading carefully. You're going to have two situations here. One is independent, the other is dependent, and then we want to find the probability. In a town where 1/3 of the days are sunny and 2/3 are cloudy, what is the probability that the next 5 days are sunny? Well, the weather on one day does not impact the weather on the next day. So what we have here is independent situation. And what I want to have is sunny, 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 and sunny. Every sunny day has a chance of 1/3 to occur. And then I will multiply those all together to get 1 out of 243 as the probability that we have sunny days for the next 5 days. Next situation, we want to select a pair of red socks on 3 successive days from a drawer that originally has 5 pairs of red socks and 10 pairs of black socks. If I reach in my drawer the one day and I take out a pair of red socks, am I going to throw that pair of red socks in there when I'm done? No, they're going to go in the hamper. And what's going to happen is what's left in my drawer is not the same number of socks as I had the day before. And that'll keep happening until I do the laundry, and then the socks all go back. But again, the number of socks is going to be different than what I had the day before. So this one is going to be dependent. We want to get red socks, and red socks. So on the first day I go to my drawer, I have 5 red socks out of a total of 15 because 5 plus 10 is 15. I wear those red socks all day. I throw them in the hamper. Wake up the next day and I want another pair of red socks. Well, now there's only 4 pairs of red socks out of 14 total pairs. Gonna wear those red socks all day, take them off, throw them in the hamper, and the next day I want to have red again. Well, that means there are now 3 pairs of red socks out of 13 pairs of total socks. Now, one option you have here is to type these values in your calculator, or some of you may see, oh, okay, I know I can reduce some of these. 5 out of 15 is 1/3. 4 out of 14 is 2/7. So you can always do a little bit of reduction first if you want. And then at this point, let's see, across the top, I'll have 6. If I multiply across the bottom, that's 243. So 6 out of 243, I can actually reduce that a little further, is 2 out of 91, or about 0.02. I have a 2% chance if I blindly reached in my sock drawer 3 days in a row to get 3 pairs of red socks. The next type of probability we're going to look at is either or probabilities that are non-overlapping. 2 events are non-overlapping if they cannot occur at the same time, like heads and tails. They are on 2 separate sides of the coin. They cannot occur at the same time. So therefore, the probability that one or the other occurs is just the sum of the 2 probabilities together. And just like before, it can be extended beyond 2 events. Suppose you roll a single die. What is the probability of rolling a 2 or a 3? Well, a 2 cannot occur at the same time a 3 can, so we are just going to add the 2 probabilities together. The probability of 2 plus the probability of 3. Well, a 2 happens 1 out of 6 times, and the 3 happens 1 out of 6 times. If I take 1/6 and add another 6 to that, I get 2/6, and 2/6 reduces to 1/3. The other type of or probabilities is when we have a thing called overlap. 2 events are overlapping if they can occur together, like shown here. Picking a queen out of a deck of cards or picking a club. So in the blue circle here are all 4 queens. In the reddish circle here are all 13 clubs. And you can see here that this card in the middle, the queen of clubs, happens in both circles. So for the probability of an overlapping event, you're going to take the probability of the first one occurring. So there are 4 queens out of 52 cards, plus the probability of all the clubs, that's 13 out of 52, minus the overlap. So this card was counted twice. It was counted as a queen and it was counted as a club. So what we have to do is we have to take out that duplicate that we have counted for. So in the end, we get, let's see, 4 plus 13, 17 minus 1 is 16 out of 52. And if I count all the cards in this circles here, I should get 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Very similar example here. What is the probability that you draw a 5 or a spade? These are going to be overlapping because we have a 5 of spades. So we're going to start with our overlapping formula, the probability of A plus the probability of B minus the probability of their overlap. So to get the probability of 5 or a spade, we're going to find the probability of a 5, which is 4 out of 52 cards. The probability of spades, there are 13 out of 52 that are spades. And there is one card that is the 5 of spades here. That's our overlap. And it's going to be the exact same answer we had on the last slide here. 16 out of 52, which does actually reduce to 4 out of 13. We've got two examples here. They're both OR probabilities. One is going to be overlapping, the other one is not. And then we're going to find the probability. If we want to draw a black ace or a red king on a single draw of the deck, well, black ace would be the ace of spades or the ace of clubs. A red king is the king of hearts or the king of diamonds. And all of those are different events. So this is no overlap. So I can just add these two probabilities together. There were 2 here for a black ace, 2 out of 52. There were 2 here for a red king. I add those together, 4 out of 52, which reduces to 1/13. Next one, randomly selecting either a sophomore or an honors roll student where there are 25 students in each class. Okay, so we've got 25 freshmen, 25 sophomores, 25 juniors, and 25 seniors. And 5 students from each class are in the honor roll. So there are 5 freshman honor rolls. There are 5 sophomore honor rolls. There are 5 junior honor rolls and 5 senior honor rolls. We want to find the probability that we pick any sophomore or an honor roll student. Well, because we have sophomore honor rolls, that is an overlap. So yes, we have overlap here. I'm going to start with the probability of sophomores minus the probability of honor rolls, plus the probability of honor rolls minus the probability of our sophomore honor rolls. All right, if there's 25 in each class, we have a total of 100 students. And 25 of them are sophomores. So the probability of getting a sophomore is 25 out of 100. Probability of selecting an honor roll student, we're still out of 100. There are 5 from each class. So 5, 10, 15, 20 honor roll students total. But we have to count out our 5 sophomore honor rolls. We've counted them twice. So I need to take away those 5 sophomore honor roll students. So if I take 25 plus 20 is 45, minus 5 is 40. Out of 100, that reduces to 2/5. Below we have a spinner, which has both colors and numbered sections. There are 12 pieces, so 1 red, 1 green, 1 blue, 2 red, 2 green, 2 blue, so on and so forth all the way around. So there's a few ways we can do this. I like to just mark them and count them. So the first option, if we want to get a blue or a 2, Well, if I look at that, I've got a blue, a blue, a blue, and a blue. But then I also want anything in the two sections. So one option is to just count all of them up. 1, 2, 3, 4, 5. That's 6 out of my 12 pieces that are blue, or 2. The other way is to use that formula. Well, blue is 1, 2, 3, 4 out of 12. There are 1, 2, 3 in the 2 section, but there is one blue 2 that I have to take away. Okay, so probability of blue, probability of 2 minus probability of blue 2 is going to give me that same 6 over 12, which is also 1/2. Next one wants us to do red or odd number. So again, you can go around and just mark all the reds. So 1, 2, 3, 4, and then mark anything else that's in an odd spot. So 5, 6, 7, 8. So I should get 8 out of 12, which is 2/3. I like to do it that way. To me, it's a little bit faster than adding them and then subtracting. Next one wants us to do red or blue or 4. So reds, I've got 1, 2, 3, 4 reds. 1, 2, 3, 4 blues. And then another one that I haven't counted in the 4 section. So 1, 2, 3, 4, 5, 6, 7, 8, 9 out of the 12 are red or blue or 4s, which is 3/4. Okay. This last one says and, so it's a little different. It says green and 3. There is only one green 3 that occurs in the entire spinner out of the 12. And I understand probability is a little tricky, so please, if you need to review these problems again, shoot me an email, ask me questions, whatever you need to do, and I'll do my best to help you. On a roulette wheel, there are 38 equally likely slots, 18 red, 18 black, and 2 green. We want to spin 3 green in a row. Well, we have 2 greens out of 38 in the first spin. The next one still is going to have 2 out of 38. And then the third one's also going to have 2 out of 38. The number of greens in the wheel does not change. Some of you may know that each of these 2 out of 38 can reduce to 1/19. So if I reduce each of those to 1/19 and then multiply the final answer, is going to give me 1 out of 6,859 chance that I'm going to get green, then green, then green. Next one, we want to purchase 5 winning lottery tickets in a row when each ticket has a 1/8 chance of being a winner. So 1/8 for the first, and the second, and the third, and the fourth, and the fifth. All 5 of them want to be winning tickets. So if I multiply, top is 1, bottom is 32,768. This is not likely to occur. And our last one here, the probability we get 4 rainy days in a row when the forecast calls for a 40% chance of rain each day. Well, one thing we need to know is, what is 40%? Well, 40% is 40 out of 100, or 4 out of 10, which also reduces, what is that, 2/5. All right, so we want rainy day 1, rainy day 2, day 3, and day 4. And then we're just going to multiply across. Multiply all the 2's is going to give me 16. Multiply all the 5's, 625. So the probability of getting rain for the next 4 days is 16 out of 625. This is the end of your lectures for this week. So please make sure you go into the Pearson homework as well as your discussion board. And if you're having any questions or problems with any of these, please do not hesitate to ask, because I definitely know probability is a little bit tougher of a subject.